Hello and welcome to a new start on the Robin Hood Super Spec video. As you probably know, we've changed the kits now so that the new packages introduced in the middle of 2004 now do not have the panels fitted, and the items on the rear axle need to be reconditioned. Therefore, the start of this video contains an introduction to the fitting of those panels and the reconditioning of the axle. This first part will just be tagged on to the original 2B video that was available before, when the kit came to you a lot more together. So we'll go off now and we'll start off by looking at the package that you actually got, which is the rolling chassis with the two axles and the engine, gearbox, etc. fitted. We'll start off by pointing out that one of the first jobs that I feel that you should do is the painting and the preserving of these front axle assemblies. As you know, these are brand new and they haven't been painted, and there isn't any protective oily coat on them either. So it's a good idea to get those painted, at least in a bare metal primer, straight away. And while you're doing it, you could probably do the cycle wing brackets or the basis for the cycle wing brackets. You could take them off, they do come off quite easily, or you could mask off and do them in situ. We can see that the steering rack's in, but there's no steering shaft. We can see that the pedal box is already welded into the chassis, as is the support for the steering column and all the inner floor panels. For your convenience and for transportation, the rear axle was put in, and that has been checked and shot blasted and painted in a bare metal primer. So the first job we're going to do now on the car is to take out the axle, because we do have to do more work to it now. We have to fit new nylon spar bushers, new rubber gaiters, and do work to the brake system. So we'll go through to the main workshop and we'll look at an axle. I would suggest that the rear of the car is jacked in the air, and that you support the body chassis unit on a plank of wood that will go straight across the stainless steel floor, and it would then go onto two axle stands. And you don't need to lift the car too far off the ground, because you don't want the axle to have to fall too far. So just elevate it so that you can work easily, and that you can put a small trolley jack underneath the axle, underneath the diff casing, and once you've taken out the bolt to hold it in, which are only 2 bolts, we could start off by taking off the rear coilovers. That doesn't need any explanation, that's quite simple. And then there is only 2 main bolts that go through the fixing just behind the seats. 2 bolts around about 90mm long, 12mm diameter, and then the 1 bolt that fits in the diff there. And you'll probably see that when you take the axle out, that the front drops out first and then the back comes out after. Remember, when you put it back in, to put it back in that sequence. People sometimes struggle a little bit to get the axle in, so just be careful. And the start of myself promoting self-preservation, just be very careful, because the axle is really heavy, it's easy to trap your fingers, and it's one of the areas that is on the fringe of the kind of work that people at home that've got limited skills can do. So just be careful when you're handling this axle. Make sure there's lots of people at least two others to help you with it, and just watch your fingers, because if you kind of hold the drive shaft just there and then it comes down, then you could trap your fingers between the drive shaft and the trailing arm, and then often when you're holding on to things like brake discs, the caliper swings around and traps your fingers. So I know I've done it, so just be careful. So we're going to go now and look at this axle. We've got it in the other workshop, and then we can go through the sequence of the things that you need to do to recondition it. I would point out that it's very much a grey area, what is required to make this axle a reconditioned unit that is acceptable to the licensing authorities. I think you've really got to use common sense here, and the reconditioning process should consist mainly of the axle being checked and being the builder, being satisfied that it is in a serviceable condition that will last the length of the time that you're going to actively use this car. The kit cars are a little bit different to mainstream cars in so much that they're not doing 50,000 miles in a year. So you may be happy to say, well, I'm going to do 4,000 or 5,000 miles in a year, and I'm going to recondition the axle so that we've got 4 or 5 years without any maintenance. So the parts that we've given you in the kit are what we call consumables. So they are all the components for the braking system, and the bearings for the axle, the rubbers for the drive shafts, the new nylon bar bushers that will replace the rubber ones in the trailing arms, and repair kits for the brake cylinders, obviously brake cables, brake pipes and things like that. So I think that you should photograph this process of the work you do to this axle, so that if there is any query at the time with the registration officers, you can say, look, this is the axle, you can see that I've got it from our supplier, they've checked it to be sound, they've shot blasted it, they've painted it in a bare metal primer, I've gone on to replace these parts, and it's quite normal for you to show them the list of the parts that you received. I've put these in, here are some photographs of the work being done, and I feel that this is a reconditioned unit. I don't really think that these people, the licensing authorities, tend to be kinder men than the SVA men, so I don't think you're going to have a problem in this area. But if any query whatsoever, you come back to us and we'll help you. This is the axle out of the car, and we've chosen to alternate between the drum axle and the disc axle. So we have to take the axle to bits. This is the main torque tube. The diff stays on the torque tube, there's no need to take that off unless you really want to. The first thing we're going to do is to take out these Allen key socket screws that hold the drive shaft together, and it's recommended that before you start you clean all the debris out of the holes of the socket screws so that you've got the correct size star drive to go in it. That is something you'll have to get hold of, they're not expensive. And then I would recommend that square on all of the socket screws you hit with a hammer, just to loosen them up slightly, and then spray some penetration oil on them and leave them overnight, rotating the drive shaft so that you can get each one treated. The next thing to do is to get your star key in them and try to take them off. Sometimes they're a little bit awkward, and sometimes you've got to revert to other methods to get them out. You may have to cut them off with a hacksaw, the heads off the hacksaw to get them off. but that sometimes causes a problem. The next thing is to take out the 12mm nuts and bolts that hold the trailing arm on. One there on each side, and then we take the caliper off. Pretty straightforward. There's a couple of bolts, 17mm spanner size bolts, to take those off, and then you'll see the small bolts take the hub off. So that will then take all the that will mean that your axle will be more or less in several bits. We can now move on to the axle on the floor, which we've got in bits already, one that we've done earlier. This is a drum brake axle, and we've stripped it down, and I don't really think that any of you will have any problem stripping it down. It's pretty straightforward, but I would refer you to a Haynes Workshop manual. I think that will give you quite a lot of information and would help you. With the drum brake axle, I do feel it's slightly easier to work on because we haven't got those socket screws to take out. The drive shafts just pull out of the sockets. Pretty straightforward. So you'll see that we've already taken the rubber bushes out of the trailing arm because they are replaced with these nylon spar ones. And also in the kit you'll get the inner tube that goes through the arms like that. What I would say, if there was clear guidelines to what you actually need to do to these axles to recondition them, then I would be saying possibly leave those rubber bushes in. Quite simply, they do give a softer ride, a more comfortable ride than the nylon spar ones, and they are quite difficult to put in and out. So I think the benefits of these are that it does stiffen the suspension up a little bit, but there are a lot of work to fit. These aren't difficult to fit, but it's quite difficult to get the rubber ones out. So to get the rubber ones out, we are giving you a bit of a tool in the kit, which consists of a piece of tube, a big washer, and a piece of stubbing. And that is just an extractor tool that you'll put through the original rubber bush, tighten it up, and that'll pull the bush out. It is self-explanatory. There's a bush that's come out. Yes? It's all right, off you go. That's a good dog. No. The viewers don't want to see you today. Come on. Nip off and savage somebody. So that is a rubber bush that's already been extracted out of that end of the trailing arm. Remember that the two sizes are different, so that might confuse you. If you find they're difficult to come out, you can hacksaw one end of them off to make it a little bit easier to withdraw. Just remember that in the kit we've given you the special fine thread set screws that go into the diff flange. I think it's a 15mm spanner size. Don't worry if you can't find a spanner in your spanner set. The 15mm is a difficult size. Not all sets have them. But make sure you do get the proper size spanner to tighten them up. That's important. Once you've got the axle in pieces like this, you may find that you want to clean up a little bit better the components, particularly the corners where the shot blasting hasn't quite got there, so you can make a nice job of painting all these in a gloss finish paint. We come to the diff. Remember, there's a breather in the diff. It's not impossible that we put a screw in there in order to stop the oil coming out during the shot blasting process. And remember, there's an oil filler bung in the back of the diff. Then you must drain out any oil that's still in the diff and dispose of the oil thoughtfully. So you've got to get that. It's a square drive that goes in the back of the bung, the filler bung. No, it's a hexagon. Sorry, it's a hexagon Allen key size. So it's a hexagon Allen key one. Take it out and then leave the axle to drain overnight, so that all the old oil runs out. And then you can, when you come to refill it, then you fill it up to the bung, and whatever runs out, runs out. My colleague here has raised a point that is obvious to engineers, but not to ordinary people. A little bit like the King's magical sweep to close it. With filling the gearbox and filling the back axle, you take out the bung out the side, and then you get your bottle that has a squirty, flexy spout, and you squirt the oil in the hole. You keep squirting it in until it starts to run out. That's when you know it's full, and then you let it run out so as it's level with the hole. Then you put the bung back in. Does that?
Yeah.
Okay, that's good. That's good. We come now to the drive shaft. So there are several different types of drive shaft and drive shaft gaiter, and I think the Haynes manual does try to help you and guide you how to put the new gaiters on. Unfortunately, it doesn't guide you very well, and it talks about buying parts from Ford, which truthfully we even 4 or 5 years ago we couldn't get, so you've got no chance of getting them now. So what actually happens is that we are supplying what we call a universal gaiter kit with this, and you will need to make or buy a fitting tool. And what happens is that fitting tool goes over there, like after you've cut the old gaiter off and you've established that the joint is all right, there's no bits of metal in there, you've cleaned the joint off, and you've then greased it, then that fitting tool goes over there like that, and you get the rubber gaiter and you put some washing up liquid on that and you push the gaiter over that. It widens out and it springs on. I'm not going to do it, it's a really difficult job, and I'm sure that today I'd make myself look quite foolish trying to do it, but it does work and you do struggle, and it is quite successful. It's a very, very simple way of putting the gaiters on. It's a lot better than the split gaiters that are recommended. So that's you can make that yourself, or you can actually buy that from an accessory shop. But it does work quite well. I think when I was doing it, I cheated. I cut that end down so that the trumpet end was smaller, and the gaiter went over easier. They are very, very stretchable. You'll be surprised how much they do stretch. But they've left this one this size because on the disc brake axle it's bigger, you've got a bigger job to get it over. So that's the gaiters on. With regard to the bearings, well, they're a straightforward thing. That isn't rocket science. You just take off that big lock nut, and obviously look at the thread before you start, because the thread on one side, on the passenger side, I think, is a left-hand thread. So don't go turning that nut the wrong way. In the box of bearings that we give you, you don't always get the nut, but you often get a nut. So with that nut you can check whether it's right or left-hand thread. So simply, that's not difficult. It's just a matter of putting it in the vise and tapping it off with a big hammer and putting the bearing back on the way it came off. Obviously with re-grease in it. all that's pretty straightforward, and I think a little bit of help, possibly from a Haynes Workshop manual or from somebody that was knowledgeable with regard to this more precise type of engineering may help you. We come to the brakes, and I always feel a little bit hesitant when we talk about brakes and people at home that do this kind of work, because often it's the kind of thing that you could lie in bed at night and worry about. So I do want you to look at the brakes very, very carefully, and what the normal advice that I give people with brakes is, before they start taking the brakes to bits, make sure they know how all the bits go back, particularly with regard to all these springs that go inside the brake drum. Now, I've got to be a little bit careful here, because with these cars that we're these axles that we're giving you, I'm not certain that all these things have been put back together correctly by the previous owner. So there's no point in me saying look inside and do it the same, because it may not be right. So you've really got to look carefully again at the Haynes Workshop manual and possibly get a little bit more advice with regards to fitting all these kits. So you get the spring kit, you get the set of brake shoes that fortunately do come with that adjuster mechanism on. Before, you used to have to take those off the old shoes and rivet them back on, but they do come with that. Please don't be misled, as so many people are, that you think you've got one brake shoe that's already worn out. There is one that's only an 1/8 thick, and the other one is substantially thicker. So many people have took the brakes off, looked at that one shoe that's only an 1/8 thick and chucked them, gone and got some more like this and found out they weren't worn at all. So the best guide is to look to see how the other shoes were that's in there and put the new ones back as they were. There is a self-adjusting mechanism that you've got to get your brain around a little bit to work out how that works, and that's important that you know how the self-adjusting mechanism works. Obviously, the discs, the drums that are in that box, there is a possibility that they've been treated with a slight oil or grease so they don't go rusty, so make sure you wash those with thinners, and then preferably paint the outside with a protective paint. Inside here we've got the brake cylinders themselves that are pretty easy to fit. There's nothing special about that. There is a bleed nipple there. Just keep the grit out of them. They're straightforward. It's the kind of thing that when you check your car for MOT every year, that you whip the brake drums off and make sure there's no leakages from those seals. And then there's the bearing kit that I referred to before. If you find the bearing kit we've given you is incorrect, then come back to us, because there are one or two different ones, but we've given you the popular one. So yeah, you can see there's some grease in there, there's the oil seal, there's the lock nut and the bearing itself. So that's obviously for lots of you, you've got the experience that's required. For some of you who haven't, then you will have to get a bit of help. Remember, you can always come on to me on the technical line, and I can guide you the very best I can over the phone. With regards to the disc brake car, that is a little bit more complicated with regards to the drive shafts and the brakes. In particular, the reconditioning of the wheel cylinders. Now, as you know, we did give you that brake seal kit, and I'm a little bit hesitant to say that it's an easy thing to fit. It truthfully isn't. And I'm also not happy with saying that an inexperienced person can do this type of overhaul to those cylinders. And at this stage now, I'd say that it may be better if you simply went along to your local motor factor and bought exchange cylinders, which aren't that expensive. There is a problem with disc brakes, and it always has been a problem in so much that it's not that difficult to get disc brakes to work and give you good braking under normal conditions. But what is difficult is the handbrake mechanism, getting a handbrake mechanism to be efficient and to pass the MOT test. So it is the combination of the handbrake mechanism and the hydraulic system for your ordinary brakes combined together in one cylinder that always causes a problem for brake system designers. And with the Ford Sierra, it does appear that they've managed to solve this problem quite well. But as cars get older, they do become troublesome. The system inside the caliper is quite complicated, and the Haynes manual does dwell on it quite well, and we've successfully reconditioned these cylinders with the help of the Haynes manual. And just to talk you through it very briefly, the main fault with the Ford Sierra rear disc cylinders, calipers, is the fact that the mechanism for the handbrake seizes up. There is a shaft that is activated by the handbrake cable that goes through a plain bearing with an oil seal or a grease seal into the main body of the caliper, and it is this shaft that must be kept well greased. The problem is that over the years, with the dust and the heat from the brakes, that this grease on this shaft turns to wax and seizes up, and also water gets in and it starts to get rusty. So normally people that are looking to carry out maintenance work to the Ford Sierra MOT work, very, very simply, if they just give that shaft some attention, then that usually gets them out of trouble with regards to the cylinders. A squirt of WD-40 onto that shaft will free up the wax, turn it into grease again a little bit, at least for another year, and you've got through another MOT. But obviously this continual emergency work like that comes to a standstill, and now you're the owner of an axle which you've got to recondition. It really means then you've got to do it properly. So it means then that you must take this cylinder to pieces, and you must attempt to put in the seals and the components that we give you in that small cellophane bag. The Haynes Workshop Manual talks extensively about special Ford tools, and obviously you haven't got access to these tools, and you're not really in a position to go on to your Ford agent and get them to lend them to you. So we've got to look and decide what we're going to do and how we're going to get around the problem. And we can start off by looking at the cylinder itself. I'll just get a cylinder so we can see it. Just bear with me. Here we see a caliper, and there you see the fixing screws, and you can see what I'd call the number one mechanism that could seize up. See the little bellows working there. Maintenance work, that's a very simple thing that you could look at, and you could clean out and re-lubricate that part there. So that comes off, we take that off, and then we look at the actual mechanism that works the handbrake, and you see there's a spring there, and then you recognise that little hook there that you put the eye for the handbrake cable, and then that will rotate clockwise, and there is a shaft that goes straight into that housing, and it's that shaft that causes the problem. There is a small oil seal or a dust seal on that shaft, and that shaft seizes up, and it looks like in this case this has seized up. So that is what you've got to lubricate and get out and to free off. And you'll see there is a bleed nipple there that again you must be careful to get that out. You may need you definitely need to try the penetration oil first. Soap penetration oil, obviously if it doesn't come, you put a little bit of local heat around that bleed nipple to get that bleed nipple out. and the same applies to the brake pipe. You're throwing that brake pipe away anyway, you've got a new one for that. So we've got another cylinder here that's part stripped down, and you can see we've taken that number one mechanism off, and we've come to the main piston. There you see the main piston, very badly corroded around the neck, but it looks like that further down it's okay. So the Haynes Workshop Manual talks about the special Ford tool to get it out. We simply use a spanner that you take the wheel off a 9-inch angle grinder with. It's a brand new one, we've not used it, and that is ideal to get into those things there and to screw that out. Now you do have to screw it out because there is a coarse thread in there, so you need to screw that out because of the coarse thread that it runs on, because the mechanism for the adjustment notches it up as you operate the handbrake lever, and it rotates that main shaft down there. Then that notches up the handbrake on the spiral that's inside. So having got that out, having taken that out, you'll see then in the deep guts of this cylinder there is what we're calling a bullet. It's like a licorice torpedo, and that joins the mechanisms together. There is another piston and seal in the bottom to be changed and to be lubricated and cleaned. So it is that main shaft there and the little torpedo that you need to clean. There is a picture in the Haynes manual. Obviously I'm not permitted to show it you because of the copyright. You'll have to buy one yourself, but the picture is really good. It shows you the torpedo, it shows you the main shaft, it shows you all the seals. We give you all those components, and you've really just got to get your head around the actual the method of doing it to change the seals. Again, it talks again about another special Ford tool you need to get the little top hat out of the middle of the cylinder. Again, we've used some very long snipe nose pliers to get it in there and get it out, so you can do that. But where I'm really coming from is that if you do this outside work to these calipers, it may be that your licensing authority man may consider that with the components you've done to the axle and this outside work to this cylinder, once you've satisfied yourself that it's in order, that with changing the main seals on the outside and the main seal on that caliper, it may not be necessary to go too deep inside the caliper. So unless the governments are prepared to issue clear guidelines on what they consider a reconditioned unit, then it may be that the axle with new nylon bar bushers, new gaiters, new discs, repainted casing, new oil in the diff, and new handbrake cable, new brake pipes, all that might constitute a reconditioned axle. So you may be okay. But in any event, document what you've done well so that the people can see that you have replaced all the consumable parts on the axle and that it is suitable for use for several years without needing any further attention. So we can put the axle now back into the car, just reverse the stripping down method that I indicated, put it back in, watch your fingers, tighten all the bolts up, and that's it. Having put the axle back in the car, we now come to the panels, and you can see here we have the main panels that have to be fitted. If you've got a turbo car, then the side panel has a round hole in it. If you've got an injection car, then the side panel has a square hole with a hole for the lander sensor. Obviously on the turbo car the lander sensor is on the what would be like the exhaust manifold. So we've got the panel, so we'll take that panel away so that we're not confusing the viewers. We'll put that out of the way. And you'll see also in the picture is the small 2 crescent panels that come already tacked together. So we come now to these panels just here, and it is necessary just to trim a little bit off the bottom of one of these panels. To get it to fit well, we found out that there is an incision that you can carry out on the bottom of this. A little bit of metal that needs trimming away that makes it fit better. So I've marked it like that. So we're going to trim those 2 little bits off, and it will make fitting the panel an awful lot easier. So you can do this with a fine-tooth jigsaw, or you can do it with a pair of snips. So if you could possibly come very close, it's quite important that the viewers can see precisely. So at the far end of the panel, you can see that we need to take that extra ½ inch off just there, bringing that close to a ¼ inch to that corner. We need to take that off, and then round here, then I just hope that you can see the kind of material that we've got to trim away from there. If you see that incision just there, I've questioned our people about this. We've had many arguments about it already, and they tell me that if they did do that, that it's pretty definite that in transit that panel would bend in the middle. So they tell me that's why they've left it on. I'd question that myself, but anyway, for you to carry on with your Super Spec now, you need to take this little piece off. So we snip that like that. We snip that like that. And then we'd probably be better to turn it upside down like that. Along there like so, and then we'll go off at an angle and reach that point just there. So obviously once you've taken that bit out, you have got to be careful, because it does make the panel a little bit flimsy, and it would be quite easy to for it to bend wrongly. So we take that piece out just there. And over to the same as the other side. That perforated section there on the bottom of the panel, we need to bend that up. So just by hand, bend that at 90 degrees. Okay? And then really, all we do now is take the bull by the horn and we put the panel on. You've got to make sure there's no weld splatter on the tubes, and there's nothing sticking out on the side of the body, on the side of the chassis I should say, that would make the panel not fit properly, or put a ding in the panel from the inside. So again, handling the panel carefully, because that's going to be quite weak now. We move across to the car. So we're looking to make sure that there aren't any welds that stick up, that if we did fit the panel close to the side of the car, then they could stick up into through the side. So you've got to make sure there's no weld sticking out. You've also got to decide at this early stage whether you want to paint the tube work inside the car a particular colour, black, and if you do, then at this stage that you've really got to paint them before you fit the panels. The other thing that you've got to consider is that you may also decide to just do a little bit of exploratory work and work out how much of the inside of this panel is actually carpeted, and you could put the carpet, glue the carpet onto the panel before you start, and that would mean then that you would have a little bit less to do later on. So that's just something you want to think about. So we're coming on with the panel now, and we've also got to remember that it isn't necessary for this panel to fit tight onto the tubes, so it can stand away from the tubes. So we can see there is a little bit of a key to where it goes, and we can see that there's that pedal box just there. So that gives us a clue to where it goes, like that, and it goes around that pedal box. And we can see that it comes up and it goes over that circular engine bay tube like that. It rides over that. And we know now that there will be a change of direction in the panel, and the change of direction will be where the top panel there terminates, and we know that it's going to bend there, and we know that that's where we cut it underneath, and it's a weak part. So if we push that in now, that should change direction quite easily. You may feel underneath with your hand, and you could feel that there's a gap there that you can get your fingers in slightly between the bottom tube. That's in order, that's all right. And you may also see that there is a little bit of movement backward and forward of the panel, like that. And if we look at the front, we can see that there's a gap there with the wishbone, which is about correct, and the same as it nearly comes up to the box just there. What I would say is that before we go an awful lot further on with this panel, we really ought to try the other panel on the other side, because it is the other panel that is more of a key panel than this panel, simply because for the car to look right and for the car to be correct, if we spin round to the other two cars we have in here, we'll see. You can see that with the turbo car that we've got the exhaust pipe exiting quite well from the centre of that hole. It's not perfect, but there's clearance all the way around the hole. And when we look at the next, we can see that is probably a better fit, that the four pipe from the exhaust manifold do come out nicely out of the square hole. Now, what we're saying is that if you do fit the passenger side panel first, and you get the exhaust coming out of the hole perfectly, then when we look at the relationship to the other holes that matter on the panel, like the gap that there is between the back wishbone and the side panel. Cameraman, can you swing around onto that car so we can see? So we can see that gap just there between that wishbone and that there, which I can just get my finger in. Whatever it is on the near side panel that we've got very little choice over, then when we do come to fit the offside panel, we can make those gaps the same. So that panel is a lot more movable. So my advice to you is fit the passenger side first, and then copy all the gaps for the driver's side panel. So we'll come back to the car that we're working on now. You ready? Mm-hmm. I don't plan on dwelling on the exhaust fitting. That's straightforward. That is something that I'm sure you can do without any guidance from me. The carry on with the panels, which are more important, is that we've already established that we've got to make sure that the gap just here is the same as the other side, and it looks like that it is. If you had to trim a little bit off that area around the pedal box, then you could do. So normally you'll find that that panel butts up to the weld on the pedal box and fits around it quite nice. These incisions, incidentally, in the panel there, is at a later date you can bend these tags down and round so they hug the tube better. At this stage now, I'm pretty certain that it would be in order to put a small self-tapping screw into the panel just there, so that you could fix it permanently. Okay, it's been decided that we're going to take the bull by the horns and put a few screws in this panel now. Remember, don't worry if you drill a hole that's in the wrong place. You can move the panel up and re-drill it. But as it is now, it appears now that the panel, as we've put it on there, is in the right place, and we need to drill a couple of holes and put a couple of screws in just to fix the panel, stop it moving when we come to the delicate rear end forming work. So you need to have, you really need to when we drill this tube, you really do need to drill it right on the apex of the tube. If you'd get to one side, then the drill tends to wander off instead. So what we're saying is that we need to be square on the top of that tube. It's difficult to do that because the panel covers it, but what you can do is take a measurement from a datum point on the outside, and that will then, when you do drill blind, then you'll know that you're going to be at the apex of the tube. So we'll put the panel back on. Remember that we're doing the other side first, having put the exhaust on, and we're going to mirror this panel so we've got the same gap at the bottom wishbone there as we have on the side that fits correctly with the exhaust. We know the measurement just here, where the tube is going to be, so we'll start at this end and we'll drill one hole just there so that we can put one screw in to locate the panel. So remember with these drilling exercises that you must drill slowly. You may need to experiment a little bit with the screws that you use and the drill sizes, because depending on the thickness of material, different screws grip differently. But that's a 4mm. That's a 4mm hole, and that self-tapping screw's gone in there nicely. So we come along to this end, and we need to fix this end, and we can see that if I press in like that, there's a little bit of resistance there. So I don't want to be pressing much more than that. And I can also see that the panel isn't up to the tube, which is not the end of the world, but I'm going to lift the panel, can you see, over the weld just there. So it was butted up to the weld there, I'm lifting it over the weld, and that's making it sit a little bit easier. And at this end, I can see where the centre of the tube is. So I'm going to drill another hole just there, like so. Remember, areas like this are totally unimportant if you get it wrong, because the scuttle covers that, so it's not the end of the world. So if you want to experiment with screws and holes, then do it this area just here, because the scuttle will actually cover that. We put that screw in like that, and to be honest with you, it's going to probably look a bit too easy. We might have been better with the 3.5, but for this video we'll make the 4mm easier. And what happens now is that this panel has to change direction, and we've cheated a bit by cutting that bit out, but normally you would have found out underneath here that you needed to trim that and trimmed it accordingly, but we've done it before and we know that's the case. So we probably want another screw underneath the panel, under here, to secure it, and we've already established that there's a little bit of a gap underneath the panel and the tube, but this is in order because we want to put a little bit of bone in that panel there to give it some shape, to stop it being wobbly. So the very fact it's a loose fit is advantageous, but feeling this, it may be a little bit of too much of a loose fit, and we may just have to put a packer in there just to relieve it a little bit. But we could really do with jacking the car up and putting a couple of screws into that tube underneath there to secure the bottom of the panel. But for the video, let's just carry on and imagine we've done that, and we're coming to get some shape into this back panel. So we're starting to talk about delicate operations now, and we're starting to talk about bending this panel. And there is going to be a change of direction in the panel round about there that corresponds precisely with the change in direction just here to the tube that you see just there. So we're now going to ease the panel in like that at the bottom, push it in, and we know that because we've trimmed those bits off that that's going to go in, and it looks like it has. And I think I'll have to ask the camera person to get down on the belly now, and the camera person is now splayed out on the floor. And we've got a close-up of this, and we can see that that tag that we bent previously is at 90 degrees. That goes buttered up to the to that dip, that floor weld, and I'm actually swapping my drill now for a smaller drill, and I do think this is a 3mm drill I'm putting in there now, and I'm going to fire a couple of screws in. Remember, it's the worst thing you can do is to leave your chuck key in your drill like that. It's a crime in engineering. So take the chuck key out, and we're going to drill a couple of holes in here, and we're going to put a couple of screws in there to secure the bottom. But because we want these screws to bite, and it's thin material, that's why we've swapped to a 3mm instead of a 4mm. So remember, you may want eventually to change these to small nuts and bolts, and then remember that all these panels, you can supplement them all with a structural sealer as well. But at this stage now, we're keeping our options open, and we're just going to put a couple of ordinary self-tapping screws in here. This screwdriver I'm using actually was it came from Everything's a Pound shop, and to be quite honest with you, it's
we can tell.
It's really good because it's got this vast choice of tips, and for £1 it's a terrific value. Plus you take that out and you've got that bit there that if you drop nuts down into your spark plug holes and you're worried, you can fish them out with that. But for £1, do you think it's good? In my next life I might have everything as a pound shop. Right, here we go again. So we can now satisfy ourselves that that's okay, and if the car was jacked up we could put a few more screws in the bottom of this panel, okay? But now we're going to come up higher now, and we're going to go and get a rear wing, because the rear wing is quite important at this stage, because we need to shape this panel according to the rear wing. Okay, we've now got the panel fixed at the top, along the bottom, and we now come to fix the rest of it. As we push the panel to the side of the body, that's virtually it. But we need to get a little bit of a bow in the panel just there, and the reason for is just to give the car a little shape. And if you see that this is the rear wing, this is your one-piece wing that you'll recognise, you'll see there is a suggestion of a little bit of shape in the panel just there. And what will happen is that we'll press that against there like that, and we'll press the panel down slightly, and we'll get a slight bend in the panel there like that. With the 2Bs there's a little bit more shape than that, and people get a horrible ding in it just here while they're doing it. So it's a good idea that you just keep your hand, or somebody's hand, pressing the panel out there, just so when you do this, it doesn't ding across there. But I can't honestly see how they managed to get it wrong. So you just press it in like that. So all I'm going to do now really is to get the panel that's sitting in naturally, put my hand on top, press it down like that to get the bow in it there, and then put a screw in there so it retains that bow like that. I mean, I know that bow's about right because I've done loads before, but you need to get your wing then and offer your wing up there to see that that bow, the shape is about right. So with the wing in the just about the right position, I can see that that guesswork that they've done isn't far off. So what I'll do then, just to make it a little bit easier, we'll get the grips, and we'll just grip it just there. You've got to be a little bit careful with these grips, because we never really know what's going to be seen and what's not going to be seen. So you're okay gripping it if you know that it's a part that's underneath. So let's go and look on a real car to see, just to make sure it is covered up. So
Yeah, looks like that real crescent's on it.
yeah, that bit is covered up, so we're okay. I've just bent back the end panel, and I'm pushing the panel down like that. I'm not just pushing it down, I'm pushing the panel out with my fingers as well. So I'm pushing it down like that, and I'm putting the grips on, and I'm trying to get them to grip on. If you've got an associate or a friend, wife, girlfriend, son, next door neighbour, to help you, that's great. So I've got that like that. I'm offering up the wing, and I can see that I've got it about right. It's not far off. I'm happy at that. Okay. So with that like that, just put it back there again. We know that that area there is all covered up, no problems at all. So we're going to fire a screw in there. So again, because we're drilling into the 2mm wall thickness tube, up it. It's actually Sunday today, that's the reason why the dog's been let in. I can only do these kind of videos in the peace and quiet of a Sunday, so I've been to church, I've come back. Yes, Sue, stop it. I've come back, and so we put the screw in there, square on. So we put that screw in just there, and then we take off the vice grips. And what happens then is that we tap the panel over the top of the tube. Now this is something that I'm afraid that you'll hate doing. It's dead straightforward. Just get your hammer, start from just there, just fit up to the tube like that. All the way along. So that gives you that nice shape like that. All you do is put a row of screws along there, every 4 inches apart, into the tube, about 1/4 inch from the edge of the panel. If you look on this car just here, then you'll see there's the screws all the way along there, 1/4 inch from the edge. You can see the shape that we're looking to achieve just there with the wing. And that's basically it, at least provisionally. So you can see that we've got that fixed. You could still put a few more fasteners in, particularly at this end, but we'll go and look at a completed car, and we'll look at, you can see there the finisher that goes on top of the panel, and that will cover up any mistakes you made or cover up all the screws you put in. So that's what you are aiming to finish up with. A cap on the top of there that you get in the kit, covered in leather cloth, that covers all those screws and pop rivets. Almost unnoticeably, there is a slight bend in that panel. I've just got a straight edge to put against it so we can just see how much of a bend that there is. So there is a bend in the side panel, and it does equate to a finger at the top and a finger at the bottom. So can you see the reflection of it in there? That's pretty good. So that gives you that slight bend in the panel that makes the panel dead straight. It's as straight as a Rolls Royce. It takes all the ripples out of it, and it just gives that little bit of shape to it. And then of course we talked about the change in direction just here. That again is hardly noticeable. Again, there's a slight change in direction there. I did look underneath the panel where we trimmed that little bit off. My colleagues are giving me bum information. We didn't really need to trim as much off as that. But I will give you some direction, probably in the form of a drawing on that panel, how much you need to trim off. But we trimmed off a little bit too much there. So that panel is great, it's nice and straight. So we're now going to move on to the back of the car now. And another area that people seem to fear is fitting the back panel, which is quite easy. So we'll set up the camera at the rear of the car and we'll carry on and do the back panel. Okay, the back panel comes to you in the form you see it now. A little bit frightening for some people. We could form it quite easily, but by the time you got it home it would be unformed. So this is why you get it in this flat form. We do put the bottom fold in for you. That is difficult to do. If you look at the panel, you'll see that there is a little tit just there. Can you see a tit there and a tit there? Two tits, right? And those tits form the line that we need to put in the panel. There is a curve in the panel, and the apex of the curve needs to be at the centre of that radius just there, and the centre of that radius just there. So we'll just highlight that tip there like that, and that one just there. So what happens is that if we projected that around there, if we had a tit in the bottom, it would be just there, and it would be just there. So we're going to join that up a line like that, and join that up in a line like that. And all that happens, it's dead easy, is you just get your hand there like that, you bend that back slightly, out the way, you just get that like that, and all you do is do that. So that that forms the corner of the back panel, and when you're looking down inside it, that is the centre of the curve. And if you come round to about like that and let it spring back, it's about right, and you're looking to push that up to see that that's going to go together like that. This side's not quite so easy, because unless you hold your hand firmly there, that it'll bend across that filler cap hole, which we don't want to do. So we're pressing there, and you might get your chum to lean on that so he doesn't get it wrong. And we're looking to get that line, that line that's there is the centre of that curve, and we're going back on itself like that, just so you can still get a grapefruit in there. That's the rough indication. Now, unfortunately, I always do this. I do it wrong. So what I should have really done is I should have bent these over first. So while it was flat formed, I should have got the ends of these. There's a little incision there. So just here, like that, and the centre of that cup just there. While it was flat on the floor, we should have just bent that over, which I'll do now, but it won't be quite so good as if I'd done it when it was flat on the floor. So that's bent over like that. It's easy if you do it flat on the floor first. So you just bend that over like that. I always make this mistake. The only thing that experience teaches you nothing. So again, we're looking for that. This isn't a tip, this is a bite. You just see it just there, just to give you the indication of the centre of that, and just there. So we're looking to fold that over. But if you did it first, it would be a lot easier. While it's flat on the floor. I'm afraid this life is a life of compromises. Good. Right, with the panel formed like that, we can bend out those two bits like that, come to the back of the car, and again, we need to make sure nothing's sticking out. There's some weld there you need to grind off, so it's smooth there. Grind off that weld. Lift up the panel like that. Set it on the spare wheel carrier. Pop those bits underneath there. And that's the panel kind of on. We need to make sure that it is in the middle. And I think the easiest way to do it would be to take, not that the spare wheel carrier is in the middle of the chassis, because in the jigging process that could just be moved to one side a little bit, but to take it that the two roll bar stays are correct. So if we were to take a straight line directly up from these holes like that, make it square off the bottom, and then measure from the centre of that stay to where that comes just there, if you made sure that these two were correct and we get it in the middle, then we'd be sure the panel would be correct. So at an early stage, I think it's important that we fix the panel to stop it moving backward and forward. And again, we have just got to take the bull by the horns and get the hammer. I'm using something like a 1.5 pound ball peen hammer. We should really be using a rawhide mallet or possibly a wooden mallet. But you will quite satisfactorily do the job with an ordinary hammer like this. So all we need to do is to planish this edge over the top like that, and then we need to fix it to stop it moving from side to side with, to start with, one self-tapping screw that is positioned exactly in the middle. Remember, that's on there like that. It fits well between the two. Just remember, when you're working with these grips like this, if you do clamp one like that and you're doing it inside the car, often with a little bit of banging, that they fall off and fall down and dent the floor, which makes it look a mess. So that's what you need to guard against. So with it gripped like that, we can start putting screws all the way along there like that. And we can work away towards the corners. Again, tapping the metal down. As we go along. The problem is that as we reach the corners where the bends are, we can't quite get the metal to go around the corners. So what happens is that we cheat a little bit and we trim some metal from the corners, but we will go further along here and still, we'll leave the corners out of it now, and we'll go further along here and we'll still clamp and screw the corners and down the sides together. But here we'll be taking up the loose metal and we'll be pushing that way so that the metal that is in the back panel is tight to the tube. Like so. We've got screws in there now and we've got screws in the side, but we can see that the amount of metal that's in the corner here is too much for us to bend over. We know that if we try to bend it over, we're going to get puckers in it. So all that happens is that we cheat a little bit and we take the snips and we snip away the corner like that. So in order to get that corner correct, we're going to take a piece out of it, and I'll draw it with the felt tip pen first. We're taking a piece out of it like that, and all it really means is that we're not going to have to bend quite so much material round the corner. So you've got left and right hand snips, but you're going to trim that bit away from there like that. And remember that anything like that, you see when you kneel on that, it really does make your eyes run. So throw that away straight away, because it is really horrible when you kneel on it. So what happens now, with it being a lot lesser corner there, a lot less metal, we'll have to tap over. So you will have screws on both sides of that to hold that. Really just with your hand like that, you're just tapping it round the tube, like that, till it goes in. Now we'll go across to a car that's more complete, and you can see the finished effect, that quite neatly, with a few screws in there, that we've managed to planish the metal tight against the tube. So here we've only got one screw in the middle, screw there, but when you finish off, these screws really need to be about 3 or 4 inches apart all the way around here. Don't worry about the corner, that's not so important. But the thing is that if we go again and look at a car that is finished, you can see that with this carbon fibre finisher that goes over this corner, that if you don't get the corner absolutely spot on, then that does cover it, and it does hide a multitude of sins. So do it as carefully as you can, and obviously that will solve your problem at the end of the day. You will need further screws underneath the panel into the tube at the bottom, and then obviously at the end of the day you can supplement the whole job with some silicone sealer. From the point of that incision, there is about 2.5 inches of gap before the wing starts. We need to put a small panel in the bottom of this corner in order to tie the corner together, and you'll be able to fix this small lower infill panel with screws through the bottom face of that returned edge and the area that is behind the wing. If we go to this car we've been working on here, then I can show you the area that we're talking about. So we need to close this area up just here. So if you remember that we bent that tag down so we could overfold that panel or overbend that panel, we now need to lift it back up, and we need to close that gap by pushing the panel up tight to the radius of that, to the radius. Now we haven't screwed this down, so that's got to be screwed down through the bottom of that tube like that. There's probably one screw in there. And then we're looking to close that gap up like that by pushing it up against there. And then we need to fit the strengthener panel in the bottom, but we can't afford to put any screws in it where you see it from the outside of the car. So as we looked at the video just a few minutes ago, we could see the area that was delicate, that was sensitive, that we couldn't put any screws in. We do know that in the bottom face of this we can put screws, and we know that the area behind this wing we put screws. So the small panel you'll get to go in there, the fillet panel that goes across the corner, we know that when we pull that up tight, we can then fasten it in through the side of that and through the bottom of that, and that will close that gap there quite neatly, give you a nice curvature, and then you can silicone seal it afterwards. There's a further panel that we've supplied that has just been tacked together like that we suggest you run some silicone sealer on the inside of that, and then that just simply goes over the top of the tube and joins the two panels together. There isn't an awful lot holds it on. We've got one self-tapping screw just there, and we know that the area behind the wing, once you've got the wing on, then you can put some fastening screws in an area that you don't see. So that goes on there. You can see the way we've left it loose on this part-built car, because you will need just have to planish those ends over the tube just so that the round tube blends in with the squareness of that corner. But again, it's an area that is covered with the finisher, with the carbon fibre finisher. So that's quite an important panel, and you can juggle that round to get that to fit the best that you can. I think it may be okay to talk now about fitting the rear wings, and if we look at the completed car across there again. Okay, now assuming that we've bent this corner over just here, and we've got the screws in that, and we've got this crescent panel in, we now come to fit the wings, and the wings only just bolt on with small nuts and bolts, obviously trapping the tadpole bead in between the edge of the wing and the body side. Remember that you will only put them on self-tapping screws initially, because it's not impossible that you may want to move them before you complete the build. And we're looking to be offering the wing up like that, so that the bottom edge of the wing, that point there, is level with the bottom of the body, just there, and that the back point of the wing there is level with the body of the rear panel. So there really is only one place to put the wing, as I've indicated. But the problem is that at this stage now, the car sits far too high because we haven't adjusted the suspension. So we're recommending that you lower the car down, if necessary by undoing the shock absorbers, so that the height of the car is about 7 inches from the floor. Because you will find the wheel will arc slightly and give you a different reading altogether. So we're looking to put the wing on like that, so that the two bottom edges are level with the body. But the most important thing is that when we come and look at this completed car just here, that when it is at the final resting place, when the bottom of the car is 7 inches from the floor, I will just measure that for you before the end of the video, that measurement there to there. It should sit 6 or 7 inches. But the most important thing is that when we've got this level just here and the back of it level with the back panel, that you've got an even space just here and just there like that. I can get nearly 2 fingers in there and 2 fingers in there. So that's what you're aiming for when you put that panel on, to get that even. If you try to put the wing on now while the car is too high, and you get those spaces correct now, when it does drop down to the right level, then it'll be wrong. The servo goes in backwards with the red vacuum pipe to the middle of the car. It goes through there like that, and pretty straightforwardly the 8mm nuts go on there to hold it in. Quite an easy job really. The next thing is the pedals, which are all on a common shaft, and you'll remember that in the kit you did get that leather gaiter and pedal set, and the pedals are supplemented with the attractive pedal covers that came in that set. So we're going to take out the common shaft, and plonk the pedals through the hole that dangle down into the compartment. There is spacers supplied in the kit so that you can space out these pedals, but the basic principle is that they all go onto the shaft, and you put the spaces in between the pedals, the washers, so to suit your own position for the pedals. So if you get them mixed up, remember the one with the big hole is the clutch just there, which goes on the inside, and the brake is in the middle. You need another set of hands ideally for this. Just remember when you're doing this type of exercise and you're using a little bit of force, that you don't go and dint the side panels. It's really important. I'm banging that against the floor, but it doesn't want to be the side panel. Remember, in the future, I could anticipate that there could be problems if you didn't use the car regularly, that you could have problems with these pedals seizing up on this shaft. So you do want to make sure at all time that this shaft is greased. But don't grease it till you finish, because to be honest with you, if you're going to take them in and out a few times to get them right, then you'll get grease all over you, so just be careful. So you can see what I'm doing, I'm feeding them onto this common shaft at this stage without any spaces, because once I've got them in, I'm going to measure the gaps that I need and put the spaces in afterwards. So that shaft goes all the way through. It goes through the hole in the other side, there's another hole in the other side, that goes up to there like that. We'll put that nut back on temporarily, like that. And the pedals are all dangling down, and you see the brake one has already fell into place through that saddle just there. So that's the pedals in provisionally, and we can see that there are gaps in between them for the washers, the 12.5-inch washers we're going to place there. So that's that. The next thing is the steering column, which is quite a complicated and quite a high-tech piece of kit, really a bit over the top for a kit car, but as you probably recognise, it's from a current loaner vehicle. And it has got the universal joints and the collapsing sliding mechanism necessary for the SVA test. So that is straightforward. There is a mechanism in it that adjusts it to go up and down and in and out. So it really is a great piece of kit. So that goes through the hole. I'm sorry, it doesn't go through the hole, it goes up to the hole that is in the foot panel, and it goes between the clutch and the brake pedal like that, and you can see that the holes that there are on that those box sections, that 3/4 box section, line up the holes, but obviously that goes on top of there like that to work. So I'll just go and get some, they look like 8mm bolts for that. I'll get some 8mm bolts so we can bolt that up. Now, with the steering column placed over the tube just there, we can lift it up into position like so. With a handful of these 8mm bolts, we can put them through the casting and through the tube. Now, just remember that we must ensure that the steering column is tight at all times, and these bolts we've given you are locking bolts. There is a locking material on the thread that does help you, but they are critical bolts and you must make sure that they're tight. It isn't the very best engineering practice to drill through a tube and put a nut and bolt through it, but in this case we've done that, and it means that you eventually got to tighten these bolts up so that they are tight and slightly crushing the tube. I can see now that these last two aren't quite going in. We're going to need to just use a little bit of force, or perhaps just run a drill. So I'm just struggling slightly to get these last two screws in here, and I'm going to probably have to finish up just putting the drill through in order to clear the hole. But they are, in fact, that one's almost there now. In fact, it's threading itself up into there, which is pretty good. So that's going up into that. What we were saying is that we need to tighten these screws up, just these bolts up, just so that they start to pinch the tube. The steering shaft is a mild steel steering shaft, and you will need to clean it and paint it, wipe it with thinners and paint it before you put it in. And that has a universal joint on the end, which goes onto the rack, and the other end goes into the...
Isn't it?
Yeah, hang on, I'll go and get the joint. The double splined female-ended universal joint goes onto the steering shaft end of the rack, and that will just tap on, and then the taps on like that, then there'll be a bolt that'll go the right way through it. Taps on a bit more. It's going to go right up to the shoulder to get the bolt on like that. So the bolt goes through it, tighten it up tight, and then the same, it goes on the steering shaft the other end. Just make sure you free that joint off. It's often a little bit tight in manufacture, so just put it in the vise, a little bit of WD-40 on it, and just make sure it is free before you put it in. So that goes onto the rack end. So we're just tapping that on to the rack end like that, and again another nut and bolt right the way through it to tighten it up. Make sure just line it up a little bit. In that case, we've got to go back with it. Put the bolt in. That goes back a little bit like that. The nut and bolt, two nuts and bolts in it, and then you'll see the other end quite clearly. And then the other end that's come through in between the pedals, then you'll see that will go onto the steering column, and the clamp that's already in there will be tightened up around it. And all you've got to do is to make sure the pedals clear. Make sure the pedals clear the rotating joint. At this stage now, we could be moving towards putting on some more panels, and it would appear that the scuttle panel would be the next panel to fit. I have this in my hand now, the scuttle assembly, that you'll see is quite a complex part of the car. It is spot welded along the front top edge and along the part of the edge that faces the occupants, and it needs to be finished off structurally with silicone sealer 1/6 on the car. So this area here that is adrift now, you could really do with roughing up the sandpaper behind the dashboard and along here on the inside of that edge, and anywhere else where the panels adrift. You do need to remove that section just there. That's been left in for manufacturing. That does need to come out. So we can just snip that out. Like so. And you really need to familiarise yourself with it. The hole in the centre is for the instruments, and the holes in the top are for the demister blowers, the two square holes. The egg-shaped holes are for the wiper spindles, and the square hole is for the heated windscreen washer jet. The cutout there is for the servo, and there are returns on the bottom with holes already cut in them that will eventually fasten them on to the sides of the body panel. At this stage, it's pretty definite that this scuttle will be on and off quite a few times before the car is completed. But sooner or later, we've got to give commitment to make a start and put it on. The quicker we get it on, then we can see where the other jobs we need to do, and it's one thing less that needs to be worried about. So, with the little piece cut off it, and obviously with the other side panel all on, we can now offer it up, and we can put it so that it goes ahead of the servo. If we just come round this side, you can see for it to sit down flat, we just need to bend those flaps up like that, and that's bringing it down, and we can look and feel anything else that's restricting it to go down. So that is now sitting on the body side, but we can see that canch of wires in the centre is stopping it. So again, let's move these, pop these back down the tunnel, like that, and away we go again. We've got this provisional fit of the side panel, of the scuttle. It's going on like that, and that's set in position. We're going to go now to a car that's a further stage of build, just to look, see if we can get some direction exactly where that should go. We can see that the rounded corner of that scuttle just there is exactly 3/4 of an inch further backwards than the end of the incision in that panel. So as we look at another side panel just here, we can see that there is the corner just here. You see that corner there and that corner there? They are the two corners. So we can see that the scuttle finishes 3/4 of an inch past there. So armed with that information, armed that we know that this car and the car on the other side of it is correct, we know that that's where the scuttle should go. We also know that we went to a lot of trouble earlier on to make sure that the two side panels were in the same position, meaning that when we measure the distance from the back of the wishbone on the car, we could get a finger in both sides. So we knew that the panels were exactly, it was down here, if you remember, we talked about that gap there being spot on both sides. So if we can take that as quite an important part of the chassis, a datum point, so we know that both panels are now in the same place, and we know that if we put the scuttle on, we make that rounded corner 3/4 inch from that corner just there on both sides, then we'll have the scuttle on square. And that the squareness of the scuttle is really important with regards to trying to fit the bonnet at a later date and the windscreen. So that's the point we're making. We know that if we put that scuttle like that, then we know that it'll be correct. So we'll go back again to the car and see if we can, without any problems, we can actually get it fitted like that. Ready? So in actual fact, where we have just plonked, to use a word, plonk, I think that's a word from another word called plonker, where we've plonked that scuttle, it's not far wrong. So we're looking at that point there and that point there. So we're pretty happy that that is 3/4 of an inch, like that. So, providing that we get both sides the same, then it does look as if that is where the scuttle should be. So what we really need to do now is, through the holes that were already in the scuttle, we need to get a marker and we need to draw through the holes like that. One, two, three, four, 5 holes. We mark through the holes and then we lift the scuttle off, and we've only got 2, I'm afraid, so we can see 1 there and 1 there. So there will be, if a pen had reached the bottom, there would be another hole there, 3, 4, 5. So what would happen then, and it is quite fortunate, it's probably more judgment than luck, that the line of those holes that we've drawn just there is in actual fact in line with the apex of that tube. So what it means is that if we drill into there with a 4.5 or a 5 mil hole, then we can put the self-tapping bolts straight into through the side panel and into the tube. So I'll just get those bolts to show you how you're going to fasten that scuttle in. They're going to head. These are the hexagon head self-tapping bolts that is used to hold the scuttle in position. They're the 6 mil hole washers that will go on. So basically, with these through those holes like that, with the washer on the inside, that'll substantially hold the scuttle in position. With the scuttle bolted down, and obviously you're looking to get the side of it very with the scuttle bolted down, you're looking to get the side flush. That is important. And obviously, because we haven't fixed the side of the scuttle, at least at the back yet, that means because we haven't fixed the scuttle at the back yet, then it's easy to line the panel up with the scuttle. However, we have fixed it at the front. So if we'd got a discrepancy at the front, if we found that the front of the scuttle didn't line up with the panel, then we wouldn't have any option but to take out the self-tapping screws and to put, to move the panel in and out to accommodate the front of the scuttle that isn't fixed. There is a little bit of movement in it. You can force it a little bit, but not an awful lot. So that's the reason why you shouldn't put all the screws in until you've obviously tried the scuttle in position. Now, with the 5 lots of hexagon head self-tapping bolts going into the tube, I would try a drill that's smaller than what you would anticipate. Probably start off with a 4mm drill, because they do bite well and they do grip well into the 2mm wall tube. So once we've got the scuttle in position and we've got it fitting flush, then it is in order then to substantially to seal off or to bond in position the underneath of the scuttle. So we've already talked about roughing up all this stainless here, so that when you've got that in line, you can put a substantial amount of silicone sealer and seal all the edges, bond it all together, including along that seam there where it's got that perforated edge. So all that can all be stuck and left a few days, and then obviously you can then lift the scuttle off to carry on doing more work under the area with the wiring, with your brake pipes and things like that. So you will have the scuttle provisionally fitted, so you know every time it goes on and off, because it's all bonded together and it is correct, then it will go together quite well. And you can work on the speedometer, the wipers and everything like that. It is important at this early stage you do try the scuttle on. The fuel tank on the Super Spec is a production car fuel tank, and you are given a 1, 2, 3 piece neck, which consists of a piece of 50mm tube that you need to push in there immediately, a small piece, and you also really need to try to put on one of the rubber tubes that we've given you. It is quite a tight fit, so you need to put initially the small short piece of 2-inch tube into there with the rubber tube on it, and then you really need to cut that bend off about 1 inch from the tank, because you'll just put a rubber pipe on there and block that off. So there is some brackets already welded into the chassis at the back, just there. You can see those with 2 holes in, and that's what the rear lip of the petrol tank sits on. So although we don't give you this in the kit, I do highly recommend that you put a sheet of 6mm plywood on this back panel. In fact, you could even put it in before you put the panel in. In fact, now you've got the panel in, you can see the total amount of the panel that is flat. Then really all that flat area needs to be covered with a sheet of plywood, for 2 reasons. One, if you're not very, very careful, when you're putting the tank in, then you could slip and the sharp corner of the petrol tank could dent the back panel. That would look a real mess. But after that, when you've got goods in the boot of your car, when you're coming back from your continental holiday, you've got bottles and bottles of wine all rattling around in the back. You don't want to be accelerating off at the traffic lights at Dover for the bottles to smash back into the back panel and dent the back panel. So you could do with plywood on the back panel as a protection at this early stage when you fit in the tank, but later for things that could be rattling round in your boot. So this goes through there like that, and we're looking to lift it up so that it sits on the brackets that's already in the chassis. Remember, it's a cracking tank, it's quite a high, the camera person's laughing now because she knows I've got the tank in the wrong way round. So that goes around that way round. It's a cracking tank, a big capacity tank with a pump, a gauge and a swirl pot all together in there like that. So that then goes in. We're looking to sit the back of the tank. Brackets that's already in there the holes, yeah, the holes line up really well. So remember, that's close to the back panel, that's why we're asking you to take that off before you start, okay? And also it's a bit difficult to get that short pipe in there, that's why we're asking you to put that short pipe in there before we start. So that's sitting on the brackets at the back, ready to put the bolts in, a couple of washers and the bolts to tighten that up. And then we have another panel that helps us to fit the tank, and you'll see that that's pretty self-explanatory. Those holes there line up with those holes there, and that just snaps. It's a double-sided panel. That just snaps over that like that. And I think it was hoped at one stage that the holes that were in there would line up with the 4 holes there, but they don't. So it just means that once you've got the tank in like that, it goes under there like that. Once that's in like that, then you will have to drill some fresh holes in the bottom of that to bolt that in, permanently fixes the tank. And that works quite well, and the tank's held in position, and it still gives you quite a reasonable amount of room in the boot for your luggage. We are giving you an off-cut pack because you are still left to fill in all the area around the back of this with little panels so that your contraband and your underwear doesn't fall out onto the road. These little panels, these tags are bent back there and that, and you can fasten those tags onto the tube. Once you've got your wings on, then you'll be able to see the limitations of how much you can drill this side panel to put the pieces of floor in that you're going to put in to block off the road from the car. So you don't be drilling in so you're exposing any screws to the outside, but once you've got the wings on, you can see the area that you can that you can fasten to the side. Obviously your coilovers have still got to go back in yet, as they did before. So that's pretty straightforward, that fuel tank. The actual mechanism for the cap and the pipe, if we look on to another car we've got across here. So when we look close up at this completed one, you can see that we've got this flexi. It's actually a steering rack gaiter that's joined together with 2 Jubilee clips and another piece of pipe in there, and then that goes on to the back of the actual filler cap base. So we'll go back to the car that we're working on. So first of all, we'll cut the small ends off these gaiters so we can push them first of all on the joining tube. This is a tight fit, but you can stretch them and get them on. Deburr them first, obviously, push them on there so you can join those two together like that. You've already got the other end that you're going to push onto the tank, and then the other end you're going to push onto the back of the filler cap. Now the filler cap itself is a cap with a rubber seal on, and the way it works is there's 7 fixing screws on the circumference, 4 of which are dummies, 3 you get in your kit, and it is the 3 that you get in the kit that go into those 3 slotted holes in the base of the cap. And you'll see that once you've deburred that face just there, that rubber seal there will go up onto that base like that. Now, there isn't a keeper for the catch. There's the catch that goes, you put the key in, and there's a catch that goes up and down there that we need to open and close it. So you will need to drill a hole directly behind the top slotted hole. Just there. In fact, I'll mark it with my pen and you can see it. So you will need to drill an 1/8 hole, a 3mm hole just there, and put a self-tapping screw in that you can turn in and out to give adjustment, so that that keeper will, when that goes in and out with your key, will click in behind the bottom of the screw. Once you've got it right, you can actually cut the screw off. What happens then is that these fingers in this panel, you need to bend those fingers round like that, because these fingers will actually space off the cap from the back. So when that's on there like that, that should go in there. That's the way it gets home. Ooh.
Sorry.
So we've got that upside down then, I'm afraid. So that goes in there like that. Can't believe it. That goes in there like that. And the 3 socket screws that we give you go through the 3 real holes. That goes onto the back and it pulls up tight, and that's the system how it works. Obviously you will still need that screw that's going to come down there to catch that, to retain it. On the floor now you see the radiator, the electric fan and the 2 radiator fixing brackets. In the nose cone, space is at a premium and everything is very tight, and to be truthful, only just fits. All we can do now is to show you the car that we put together, and you can see how we've done it and what you're attempting to do. Now, basically, only by very carefully looking at how this has gone together, then will you be able to continue and to put these components in. And this has obviously been compounded into a more difficult task because it has also got the intercooler for the turbo. Now, the nose cone does sit on these 2 brackets that protrude from the front of your chassis. It sits on top of those, or it could sit underneath it. And you can see we've drilled 2 holes in those to pick up the underside of the nose cone. And you can see that there is just probably an 8mm gap between the bottom of the radiator and that bracket, with the radiator sitting on the front cross member. And we could safely say that the radiator protrudes forward of the cross member for about 1.5 inches. Obviously the switch being at the bottom, that's how you know where the switch is. The radiator goes underneath that front square box section and then on top of the back member. So it is a tight fit and it really won't go, you can't get it wrong because it won't go any other way. And we can see that when we look at the front plastic cover and the back of the radiator, that that gap there is approximately 2 inches. Now, we can't see the fixing brackets for the radiator here simply because they are actually covered up by the additional brackets that there is to hold the servo in position. But we can go across to the other car and we can feed the radiator in and show how it would go. Later we can see that there are 4 fixing brackets from its original application. We do need to cut those off at the side. Side member isn't fastened onto the core of the radiator, so you're okay, you can cut those off flush. So the bottom 2 fixings need to be cut off with a hacksaw. We've now cut off those bottom 2 tags, and I've noticed that the radiator has come with some bolts in the side. Now, our technicians have put these in. What I don't want you to do is to put these bolts in here and find out that they're too long and they encroach into the radiator. So with a depth gauge, we're pushing it in the hole, and we can see that that's how deep the hole is before we reach the core of the radiator. And we can see that that's great. That's why they put them in, the 1/2 inch long, and that means that you can't damage the radiator. So whatever you do, make sure that it is these short bolts that go in there and not the longer ones. So with those bottom tags cut off, we're going to offer the radiator up through that hole like that, like so, and then through those 2 tubes at the front, and we agreed it was going to go 1.5 inches forward of the front member, and we've got 2 inches just here, which is what we've got. And then what's happened then, that it looks like that these brackets have been made like this for these to come out of the side. That to sit on there like that, and the screws to go into there. And that's basically the main fixing of the radiator, which is pretty straightforward, with it resting firmly on the other members. So that will locate that for you quite well. Remember that this is a high quality radiator, it's an all metal radiator. Don't worry if the radiator isn't square in the hole. It's important that you get everything in here. Remember, it's an all metal radiator, it will last a lot longer than the normal plastic types. These are for an oil cooler should you ever require them. But be careful, it is delicate. You can quite easily puncture the core of the radiator, the waterways. But with it being brass, you can solder them up if you get a problem. So with that on like that, we're going to go back now and look at the other car that's complete. And we can see that we've just got the radiator fan sitting on top of that square box member, and from 1 inch by 1/8 thick flat metal strip, they've fabricated 4 brackets, 1, 2, 3, 4, to suspend that fan in a sympathetic position to the radiator and to the nose cone. So that's something that you've really got to do yourself. You've got to make those 4 brackets, and we've bolted them on through the fixings that's already in the electric fan with small 6mm nuts and bolts, and then we've tucked them straight into the chassis with those self-tapping hexagon-headed bolts that we've got. You can see that if you've got a turbo car, that it is quite a tight fit, because the intercooler, the heat exchanger, goes directly against the core of the radiator, and it's supplemented by 2 more magic brackets that kind of go over the top of the brackets I've just showed you to hold the radiator in. So that is quite a tight fit. And then you can see you've got hoses, radiator hoses, that you will get in the kit that are shaped, and they come off at 90 degrees to go up there, and then it looks like that they are supplemented with a straight metal pipe, or it's a crank metal pipe actually, and then it goes backward into the bottom takeoff of the water pump that's on the side of the engine. And then of course the top here is more visible. You can see that there's a hose, a 180 degrees hose that comes off that top thermostat mounting. It goes across the top of the radiator with a straight pipe, and then there's a 90-degree bend that goes into the top of the radiator. All the pipes are very difficult to put on. You've really got to spend a little bit of time with that to get them right. But that's basically the fan, the heat exchanger and the radiator itself. If we look at the ducting, the rubber pipes and the metal pipes for the heat exchanger, well, there again, if you see that, if the camera person moves round, then you'll be able to see how they go. Again, it's a difficult thing to get all the pipes in, and we feel that we've done the best that we can with them. I'll lift the bonnet off this completed car, and you'll be able to see some more pipe work, so that you've got some idea where it goes. If the camera person wants to wander around the car with the camera, then I'm sure that'll be quite valuable for people building it. I think most of the pipe work you need to get from the other side. You can see how we've got that 90-degree 3/4 inch pipe that comes out of the top of the header tank of the radiator. It then goes across the engine with the metal pipe joining it with the bleed nipple just there, and then the pipe then goes into the, so we'll see where it does go. The other end of this pipe does go into a Y pipe, one end that goes into the bottom of the expansion bottle, and the other end goes to the rail of the manifold. You can see that that top pipe out of the expansion bottle goes along there and picks up with a metal pipe that's on the engine, and then goes into the thermostat housing. And then you can see that the top pipe on the left hand side of the radiator goes along there and back into the back and the bottom of the expansion bottle. And remember that all pipes must be clipped away. The nose cone infill panel comes as a flat panel. You have to put that 90-degree fold on the bottom, and basically there is a little tit sticking up there 2 inches from the edge that you need to fold along that panel like that. So you can either fold it along or you can trim it off. It now has to go in here, which is a little bit of a tricky job. So you've got to feed it in around the rack, around the wishbones, etc. So I'll have a go at this. So I think it goes like that, through there, through the bottom, back of the shock absorber on top of that tube like that. We just force that underneath there like that, and there's a little blob that needs to go behind the panel that we're going to force in, that's it, it's gone in, and then that sits up like, it goes in there like that. So once the nose cone's on, then a bit of a carefully placed self-tapping screw here and there or pop rivet will hold it on permanently. We come to fit the nose cone, and you've really got to do the nose cone before you fit this, and then you've got to make sure that the intercooler does go in afterwards. But basically, the nose cone, the bonnet is made precisely to fit the scuttle, and we'll start off by putting some masking tape on the edge of the scuttle like you can see, so as not to damage the scuttle. And with the masking tape on there, then simply the bonnet with the plastic edge trim is placed onto the scuttle so that it overlaps the scuttle about an inch, like so, and the bonnet sits on the body sides like that. Now, I must confess that looking at this now, it's not looking that promising, because we've already got the heat exchanger higher than the front of the bonnet. But in actual fact, what happened then was that once we'd got the bonnet in its position and with the masking tape on the scuttle and with marks on the masking tape so we could see that we'd got the bonnet an inch further forward than the back of the scuttle, then we felt it safe to put the bonnet catches on the back of the bonnet. And the problem with this type of exercise is that you really don't get two goes at these bonnet catches. You've got to get them right in the first place, and there is some written instruction with measurements of where to put them. So they went on like that, and you can see that the bonnet is almost self-aligning. So we've got them on there, and then we decided to put the front ones on like so, and it's all starting to look quite good because we've got the bonnet being held up by the actual intercooler. But remember that we'd done all this without the intercooler, and we had to force the intercooler in afterwards. But basically, with the bonnet on like that, we knew that that was the space then that we'd got for the nose cone. So when we then decided to fit the nose cone by feeding it in to underneath the bonnet. So we knew it had to sit on top of those little legs that's on the front of the chassis. So we then fed the nose cone in underneath the bonnet like that. As you could see, we put masking tape on the nose cone so we didn't scratch it while we was doing it. So that was fed in there. It was a lot easier without the intercooler. So that's going in like that. And with the nose cone infill panels in, that they went underneath the nose cone like that. Or it may have been that we fitted the nose cone without the panels. So we can put this side in so that needs to go underneath, so we'll start again.
Release the bonnet and the front.
Oh, it's a good idea. The cameraman says release the bonnet. That's a fantastic idea. So that's going to go underneath there, like that. So I think it is easier to do this without the nose cone infill panels in, and you can do that afterwards. So that was how we started off with the nose cone, and that is in position now. If we was to take off the bonnet, we would find out all the holes lined up, but basically that is where you would start, trying to get the nose cone to fit like that, and then you would then try to put the screws in that hold them in. But it is a fiddly job, and obviously it makes it more difficult because you've still got to fit the intercooler in there afterwards. But we've cheated a little bit in so much that we've got that in already. But it is all a tight fit, and you will have to try the best you can to fit it. With the bonnet held in temporary like that, then you've got to sit back and make sure you've got the nose cone square. If it is then you can get in and fix these screws that are underneath here that we've already drilled, and I can see that the holes line up. So those screws that go through the bracket will go into there like that. So we've got some 6mm screws, so they can go into that with the nuts and bolts and permanent temporary fix that in position. So once you've actually got it held in down there and you've bolted that up quite tight, it's then safe to come around the side like this. So basically what happens is that once you've got the nose cone fixed tight at the front so it can't move at the bottom, then we know that we've got the bonnet holding this down just here. We know the relationship that there is between that headlamp plate and the bottom of the nose cone just there. Then we're safe to take the bonnet off, hoping that the nose cone doesn't jump way out of position. So we know what we've got there, we've probably measured it, or we've got a gauge in there or something like that, and then we can actually take off the bonnet that's great. We can take off the bonnet and we're safe to put a screw in there like that. So obviously we've done this before. We should be able to get probably only a self-tapping screw in there, but we can put a screw in there, drill it and put a screw in there, and that fixes the nose cone. Obviously once you've sat back and looked at it and you've satisfied yourself that it is square, then you can put a nice nut and bolt through it. Remember there's still the headlamp cover plate to go on top of there, and you've still got the nice snap-on edge, the black edge to go on the end of that to finish that off. Remember that the floor is double skinned, and you will receive another set of inner floor panels that simply just drop into place and line up with the holes that's already in the floor. These are just stuck in with ordinary silicone sealer that you get in the kit. Again, there's quite large holes in the floor pan, and they will line up with the holes that's in the bottom of the Recaro seats. So the seats, although they're a little bit tight, they do drop into position and they just bolt straight through the floor with the bolts into the captivated nuts that's in the bottom of the seat. The handbrake again is very easy to fit. That just bolts through the holes that's already in the floor. The prop shaft is straightforward. As we said, make sure you use the proper fine pitch bolts that go into the diff flange, and then at the other end you'll be given proper bolts for the 3-bolt fixing that goes onto the end of the gearbox. 2001 video is the windscreen surround material. We've had this specially made so that it's correctly rounded for the SVA, and it also has a recess in the bottom to accept a T-shaped rubber seal that presses against the scuttle panel instead of the silicone sealer that was used previously. This is a tremendous step forward, and it will enhance the appearance of your 2B. It's made from aluminium, and it's very, very easy to flat down with 1200 grit paper and polish up using a lamb's wool bonnet on your Black & Decker drill. It will come up just like chrome. Although it is SVA correct, and although the windscreen is kite marked, we're still not advising you to fit this for the SVA test. You'll get through your test a lot easier without it. But of course that's entirely up to you. We'll start off by showing you the 2 sections. You can see, if we can get close enough, that's nicely rounded. That's the top, and the bottom is rounded the same, but there is a T-shaped slot in it that we put into it, that T-shaped rubber seal, all of which you now get in the kit. That is unfortunately eroding our profit away. That pushes in there like that, makes a terrific job of finishing it off. All the glass that you receive is toughened glass, and as I said before, it's kite marked. So just be careful not to slide this about on the bench too much to scratch it. Preferably put the kite mark down in the passenger side corner. With the aluminium frame and the glass, you'll also get a length of glazing rubber. This is pretty straightforward and is often mistaken for something else. It is just flat rubber of the correct thickness that pushes into the rubber seal like that. So before you actually start on that, putting the rubber seal in, it's a good idea to get the glass and to try it into the frame, because these frames are very easily distorted, and it's not impossible between receiving your kit and getting it home and a few months later getting it out, it could have got slightly bent. But no, we're looking at that, that's perfect now, and as we withdraw it we can see that there is equal amount of glass that's gone inside. So we can see that fits okay. If it hadn't fitted very well, then you'd find this aluminium is quite easy just to form in your hand and to slightly tweak it if necessary. So you notice I'm putting the glass on that piece of material there to stop it getting scratched. So we're going to carry on now, and we're going to get the rubber seal. I'm going to push it, feed it into the aluminium channel, which is quite easy. Having said that, it's always easier to have 2 people doing this job, so if you've got an assistant, wife, girlfriend, small son, next door neighbour, granddad, to help you. Right, after you've got the rubber pushed into the channel, then if you lay the channel and the rubber on the table and put the glass on top, then you'll be able to see where you've got to trim it off. So that goes on top like that, and you can see, we just mark it with a pen just there. We need to cut that rubber at the end just there. There's a piece that's left, you're going to need that to put on the bottom. Okay, so that's cut and that goes on the bottom. So now with the that trimmed off, we're going to feed the glass into the rubber. And it's always a little bit difficult, and you really do need 2 or even 3 people here to help you, because the rubber, as you can see, has wrinkled at the corners and it's difficult to get the glass in. But I'll struggle on here and just open that up and gradually feed it in to the corner, like so. That's good. And you can obviously use a screwdriver to help you with this, but watch that you don't chip the glass with a screwdriver. The extra pair of hands is really useful for just holding the rubber back in these corners as you push it down. Now, don't be tempted to put any washing up liquid on this, and don't be like so many of these tubular builders are. They want to be more royal than the king of themselves and put mastic sealer on this, because it is really messy. There's no need for mastic sealer. You can, this does seal okay without. So you can see that I'm struggling a bit to get the glass in the corners, to watching not to get it trapped, as I did just there. As I say, that helper would be really useful. Right, and we've got that, what I call a started. And what I'm going to do now is to bang that like that down. I'm going to do it on the floor. It's a bit more solid. So with that started all the way, I'm going to gradually just tap that down like that, making sure that the rubber isn't trapped. This surface to push the glass well into those corners, and if we peel the rubber back, we can see how far it's gone in. And it does feel as if it's gone in enough to me now. Like that, it's gone in. Right, we now come back to the table. So with that fully in, we now get some tape. I've always found that brown tape is the best. I'm using brown tape to pull the 2 legs of the screen together as far as they'll go. Like so. Pulling those together. Like that. That's what I can pull that well together. Pressing the tape. so. Right, with that together we'll just double check and look, yes, the windscreen's still well into that channel. And the next thing we're going to do is just trim off these corners a little bit to expose around about ½ inch of glass. We're trimming off the corners like that. That's already exposed enough. It's been formed, and we're now going to put this on the bottom, but first we'll lay it flat and we'll lay the glass on top of it like so. And we're looking to get, remember, we know how far the glass will go into that channel, so we're trying to lay the aluminium bottom rail underneath the glass so we can project how it's going to be. Now, it's important that the two curves in that you get them equal. Maybe a little bit confusing because you might find that one leg is slightly longer than the other. So when you've got this in the perfect position for the curves, you may find that one part of the aluminium is sticking out further than the other. But nevertheless, we're going to get it like that, and we're going to lay it there. And looking at this, this seems pretty good at this stage now. So, with that like that, what we really need now is quite a precise scriber. So we're going to get a scriber and we're going to scribe down the inside of that top frame onto the bottom frame.
Okay.
So with the aluminium placed onto the glass and with these two curves there being identical, we're going to get a scriber, and I've just got a sharpened up self-tapping screw there. You can use a sharpened up screwdriver or any bit of tool steel or old drill. So we're scribing down the inside of that. Do it with a scriber rather than the felt tip pen because it's more precise. So we're scribing down there and we're scribing down there. We're taking the aluminium out and we're cutting off the two surplus ends. So I'll lift that off. I'll mark it with a marker so you can see it. So you, the viewers, can see it. So it's just like that and like that. I'm now going to get a hacksaw and square on as I can, and I'm going to cut those two ends off. And then cutting on the wastewood side of the line, we carefully make a start and precisely cut down the line. Now, this would be better if it was in a vise. If you do put it in a vise, make sure that you do put some soft jaws in the vise so that you don't damage the aluminium. Be careful that the hacksaw blade doesn't slip and scratch the good bit that you want. If you do get any hacksaw marks in it, file marks or anything, you can rub them out with wet and dry paper and polish them, as I said earlier. You'll notice that I have previously marked an X onto that leg and onto that, simply because there could be a slight difference in the angles of these two legs, and that was the side that we marked. If we got mixed up during that process of cutting and we put it on upside down, you may find that those joints that we made weren't quite so good. So that's why we've marked that. And in any event, we've looked at the frame, examined the frame before we've put it together, and we've chosen the side that's of the highest quality to be of the front, where the kite mark writing is. So if there's any little imperfections in the aluminium, any marks that may show, then we've got them at the back. So we've now got the aluminium cut. I'm going to offer it up, and you can see that looked pretty good. That's gone on there in quite a nice tight fit. So it just leaves now to glaze with rubber the bottom edge of this strip, as we did before, and push it on again. So we're making sure that's long enough, and starting at that end, just as we did previously, we're going to feed that into there. It is a good idea just to file the sharp corners, the rough corners off the ends of these where you've cut them. So we're feeding that. It's easier on the bottom, it's not nearly so difficult. We're feeding that rubber into that channel all the way along. Holding the rubber in the position it'll be when it's in the car like that, we then get a marker and we mark it at the end like that, where we want to cut it. So we mark it just like that, so that we can snip that end off like so. Save those little bits of rubber. They're coming for all kinds of useful things later on in the build, like putting around the windscreen wiper spindle holes. So with that cut like that, and with the cross at the proper end, we're now going to feed this on. That's fed on there like that, and that's pressed on tight like that. Now it might be a good idea for you people at home to put more of this brown tape around it. At this stage now, it is a good idea to get a measuring tape and measure the distance between the aluminium on both sides to make sure you've got the frame on square. If you find that it isn't quite square, it's a little bit out, then you can get the windscreen frame like that, and you can cap it on its end like that, or like that, slide the glass around to give you the advantage that you need. It's usually 1/8 or 1/4 inch. Make sure you have got the frame on square. You can see now that we're progressing well with this windscreen. It's looking pretty good. I can see we've got these radiuses nice on those corners. So the next thing is to fasten it all together. And we fasten it together simply just with a couple of long self-tapping screws by drilling through the corner. So you get these in your kit. If you look in your nut and bolt box, you'll see you've got screws, countersunk, number 6, 1.5 inch long. They're supplied. So you need to drill through the corners of the aluminium. A little bit of a tricky job. If you miss it first time, you can still put some more screws in. And it's relatively forgiving because the windscreen pillar does cover up any mistakes you make. So if the camera can see this, we're aiming to go through that at that kind of angle. You examine it yourself before you start, you can see what we're aiming at. So we need to pick up that inner frame. Again, we're going to drill with an electric drill. It's a good idea to put a new drill in this before you start. It just helps a little bit. Say when.
Okay.
Starting with the drill square onto the aluminium, directly in the centre of the channel, I'm going to start off drilling. Now you'll notice I've got my 799 Power Devil drill that I bought from Sainsbury's home base. It's perfect for these smaller holes, not so good on the big holes. So I'm starting off by drilling square on like that, in the middle of the aluminium. Once I've got started, I'm going to move my drill in line with the line I've marked. And I'm aiming to go through there like there, at an angle, and pick up the centre web of that. I'm also with the finger pressing against the bottom rail to line it up so it's level with the top rail. So I'm also holding that in position so that I line it up with that top, line it up with the side rail. So can we see this, cameraman?
Mm. Yeah.
So I'm now going to drill right the way through the two. And I'm being very careful not to drill through my finger. That's through the first one. You could do with somebody crouching down at the drill level where the camera person is, just to tell you whether or not you've got that drill straight level or not. Or you could mount a small spirit level on top of your drill. Cool, that'd be a good idea, wouldn't it, eh? Put it into the main web. I've gone right through, and yeah, that's absolutely perfect. Could you just take a photograph of that, please? I'm going to turn it round and do the same at the other side. How to think this, I've got a 10mm drill in, and again I'm going to hold the drill square onto the aluminium, and then I'm going to tip it to the side like that to follow the line of the hole. Be careful that you don't drill too far. And that looks about right. And now we'll pop the screw in. Again, spying down the line you've drawn so you pick up the hole in the bottom rail. And you can feel it bite now. You're going to hold that in line so it's pulling it up flush. You see the screw coming through the other side, and that's, you can see that now. Can you pull it up together like that? And that's perfect. What we'll do eventually is grind the end of that screw off with a mini grinder and probably just flush the head of that off so it's flush. That's in there for keeps now. Do the same to the other side. We're now going to cut the corners off this screen. And we need to follow that bottom line like that, and then we need to project that curve on like that. We need to cut that off now. Again, cutting on the wastewood side of the line and spying down the blade, guiding the blade with the finger, and start to cut. And it is quite important that you do spy down there And it's also a good idea that you only cut halfway through, because you can then turn the windscreen over and spine down the same process. You can do the other side, and that'll give you a perfect cut. Cut the other side. We're now going to take off the parcel tape from the window. Remember, full tape, parcel tape and masking tape. The quicker you can get it off after you've used it temporarily, the better. If you do leave it overnight, the glue just from the adhesive does tend to stick on and you can't get it off easily. You can see already that it's leaving a residue on the glass, which is unfortunate, but that'll come off with a little bit of cellulose thinners or white spirit or something like that. So with the tape off, the next thing is to trim off the glazing rubber, which you will need a new sharp Stanley knife. Make sure you do use a complete knife and not just the blade. So with that, into the corner of the glass like that, and the corner of the aluminium, we're going around there, pressing well into the corner, so if you do scratch the glass you won't be seeing it. Go right into the corner there, and you can feel that it's cutting nicely, trimming it off like that. And that's that. That's the screen very close to being completed, or one of the last jobs, and that is to fit the lower seal. Now, you may find in the manufacturing process of the bottom rail that the ends of that curve have closed up slightly and it's difficult to get the rubber in. We did struggle and we did get the rubber in there without too much of a problem, only to find that when we fitted it to the car, we didn't want the rubber in those corners. So basically, you'll feed the rubber all the way in, apart. When you come to those bends that you'll stop, you'll leave it loose. Because as we'll see, what happens is that you need to pull the ends of the rubber in a different direction in order to get the slight bulge that appears in that corner. So you'll put the rubber in there apart from the ends. So if you start from the middle, if you mark the middle so you know what you're aiming at, so you've got the equal amounts on both sides, then you can see that that is in the middle, just there and there. Do it from that side so you can see it. So put it there like that, and with a bluntish screwdriver, just push that in to the channel. A little bit tricky. That's it. Hook the back in first, and then just push the front in. Careful you don't slip, you don't poke your finger, scratch the aluminium, etc. It's a slow job, but definitely 1,000 times better than the previous system we had of using a silicone sealer. Take this pen, don't we?
Okay.
I've almost got this rubber in, or I've got it in as far as we've decided we want to put it, and that is up to these corners. Once you've got it up to the corner, then stop then. It doesn't have to go all the way. Just get your screwdriver and run your screwdriver along the groove, both sides like that, to make sure it's gone well into the teeth. And that's virtually ready to fit onto the car. Now, we did manage to get the rubber right into the corners and right up to there, and then cut it off on one car, only to find that when you put it onto the car, that this corner didn't sit down, it ruched. So we found it better not to put the rubber into the groove at the corners, because then when it does sit on the body, then you can drag that around like that and trap it underneath the pillar and underneath the windscreen just there, and it takes that ruchness out of the corner. But you'll find that out yourself when you come to do it, just by your experience. So that is the rubber in there. We've still got to trim off those little screws that stick through, and that's ready now to offer up onto the car. Remember several things. That it is a good idea to polish it all with a machine before you assemble it, but you will need to finally go over it again afterwards to get any marks off, because it is relatively soft, the aluminium, it marks when it's on a table like this, or you can polish it in situ like this. The other thing is that, as you know, those of you who have already bought hoods from us, that you do have to drill this frame to put the poppers on, the frame for the hood. It may be a good idea to drill this before you put the windscreen together. You will see, if you look at this section of the window frame, that you'll see that the glass goes in there like that, and when the rubber's in, it does mean that you've got possibly 1/4 of an inch of material there that the little screw or the pop rivet will go into. If it was to encroach past the rubber, then you would find it's not impossible that the very sharp end of the self-tapping screw, or perhaps the pop rivet, would puncture the glass and cause it to shatter. So it may be a good idea that those of you who have got hoods or are thinking of fitting hoods, to put these poppers to the top of the frame before you start. And any material that sticks through from the screw or pop rivet you can grind off, or satisfy yourself it's not going to reach the glass.